Hi everyone, welcome to my YouTube channel Erudispace. I am Dr. Mohanty, and today we'll discuss about the gas turbine cycle with intercooling, reheating and regeneration. While discussing the uses of intercooling, reheating and regeneration, we have discussed in detail the utilities of the intercooler, reheater and regenerator. In fact, the intercooler and your reheater helps in improving the work output of the cycle, whereas the regenerator helps in improving the efficiency of the cycle. All these three components are integral part of the cycle which we are going to discuss today. So let me first draw the schematic diagram of the cycle. Here, first you have a compressor. This is known as your first stage compressor. Then it is taken to an intercooler. Then we do have the second stage compressor. After that, it is taken to the regenerator, and then you have the combustion chamber, and after that it is taken to the first stage of the turbine. Then it is taken to the reheater. After that, it is taken to the second stage of the turbine. Finally, the exhaust is taking place. So you have air in, and this is your exhaust gases. This is the first stage compressor. This one is second stage compressor. This one is the first stage turbine. This one is your second stage turbine. This one is your intercooler. This one is your regenerator. This one is your combustion chamber. Where heat and fuel are added. This one is your reheater. This is also known as your reheated combustion chamber. Here also heat is added. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, and this one is your 10. So let me explain the cycle. First, air is taken in. It is taken to the first stage of the compressor where it is compressed. After that, it is taken to the intercooler where the temperature of air is cooled at constant pressure. Then it is taken to the second stage of the compressor where it is compressed to a higher pressure. After that, it is made to pass through the regenerator, and in the regenerator the air actually receives heat from the exhaust gases, and after that it is taken to the combustion chamber and in the combustion chamber heat and fuel is added to this. So huge amount of pressure and thermal energy is developed. It is taken to the first stage of the turbine where it undergoes expansion. This is also known as your compressor turbine because the first stage turbine actually meets the requirement of first and second stage compression, and compressors are your power consuming devices, they are not your power generating devices. After that it is taken to the reheater. In the reheater actually again heat is added to this, then it is taken to the second stage of the turbine where it expands and develops work output. After that the exhaust is made to flow through the regenerator and it flows counterflow to the direction in which the air is leaving the compressor and entering the combustion chamber. By providing the regenerator, the amount of heat to be supplied in the combustion chamber is reduced. Now I will draw the PV and TS diagram. This is the PV diagram. Similarly, the TS diagram. One, two, three, 4, 5, 6, 7, 8, 9 and 10. So the cycle is also represented in terms of PV and TS diagram. So first you have isentropic compression taking place in the compressor. Then we do have the intercooler, and this is the net work saved by reducing the compressor work by providing the intercooler. After that it is taken to the second stage of the compressor where it is compressed to the highest pressure that is possible, and then 4, 5 actually represents the heat recovery where it receives heat from the just gases. 5, 6 is the heat added in the combustion chamber. 6, 7 represents the expansion in the turbine where we get the work output that is required to meet the requirement of first and second stage compression. Then 7, 8 is the heat added in a reheater. 8, 9 is the work that is obtained due to expansion in the second stage turbine. And then you have 9, 10 where actually heat is delivered from the exhaust gases to the air that is leaving the second stage compressor and entering the combustion chamber. So by providing reheating, this is the gain in work output that we get. So in this arrangement we do have heat work output gained by reducing the compressor work output gained by increasing the work output by providing this reheater, as well as improvement in efficiency by reducing the heat supplied by incorporating the regenerator. And all of us know that the performance measures of the regenerator is what we call your effectiveness. and effectiveness of the resonator is T5 minus T4 divided by T9 minus T4. That is the ratio between the actual temperature rise to the maximum possible temperature rise. Actual temperature rise is from T4 to T5, but the exhaust gas is entering the resonator at T9. So this is T9 minus T4 represents the maximum possible temperature rise. But effectiveness, as you all know, is always less than 1. Now, as far as the efficiency of the cycle is concerned, efficiency is always equal to the net work output divided by the heat supplied. Here, the net work output is the power that we obtain in 2 stages of the turbine, that is WT1 plus WT2 minus the work that is consumed in both the stages of compression, that is WC1 plus WC2 divided by the heat supplied. Heat supplied is QS1 plus QS2, because this is the heat that is supplied in the combustion chamber, and then this is the heat that is added in the reheater. So we are all well acquainted how to compute the work output when it comes to your turbine and compressor. You can put these values and find out the efficiency, and in terms of enthalpy difference, if you substitute this by the temperature parameters also, you get the same result. So this arrangement actually helps in improving the work output, because both the reheater and the intercooler contribute towards increase in work output, and the efficiency is improved by providing the resonator, which actually utilizes some amount of waste heat. So this actually completes a series of lectures related to the gas turbine cycle, where we have considered the uses of components like intercooler, reheater and resonator. Then we have considered the different cycles, where first we considered the combination of intercooling and reheating in gas turbine cycle, then intercooling and regeneration gas turbine cycle, then reheating and regeneration in gas turbine cycle. And in today's lecture, we have considered all the 3 components. So I sincerely believe that your concept about intercooling, reheating and regeneration, when they are used in isolation or in combination in gas turbine cycle, would be very, very clear. And I sincerely believe that this would help you in understanding the operation of gas turbines. But if you have any doubts related to this, please do put questions so that I will try to answer. Thank you very much for watching this video. If you have any doubt related to this, please do put questions so that I will try to answer. Hope to see you soon for another lecture on my YouTube channel Erudispace soon. Again, thank you.